Welcome to the lesson on mode and median. In the lesson, we will be able to define mode of grouped data, calculate mode of grouped data, define median of grouped data, calculate median of grouped data, and calculate median of data using graphical representation of cumulative frequency distribution. Mode is that value among the observations which occurs most often. That means mode is the value of the observation having the maximum frequency. In a grouped frequency distribution, the class with the maximum frequency is called the modal class. The mode lies in this class. Here the maximum frequency is 23 and the class corresponding to this frequency is 35 to 45. So the modal class is 35 to 45. The mode of a grouped frequency distribution is found by using this formula. Here, L is the lower limit of the modal class. H is the size of the class interval. F1 is frequency of the modal class. F0 is frequency of the class preceding the modal class. F2 is the frequency of the class succeeding the modal class. In this example, lower limit of the modal class is 35. Hence, value of L is equal to 35. Frequency of the modal class F1 is equal to 23. Frequency of the class preceding the modal class F0 is equal to 21. Frequency of the class succeeding the modal class F2 is equal to 14. Size of the class H is equal to 10. Upon substituting these values in the formula and simplifying, we get mode is equal to 36.8 years. Measure of central tendency, which gives the value of middlemost observation. Consider a grouped frequency distribution of marks obtained out of 100 by 53 students in maths examination. Let's try to find its median. We will first compute the cumulative frequency for each class. The grouped distribution with classes and their cumulative frequencies is called the cumulative frequency distribution. This distribution is called cumulative frequency distribution of less than type. We first find the number of students who have scored marks less than 10, then those who have scored less than 20, and so on. This gives us the cumulative frequency as shown. Now we will find n upon 2, which is equal to 26.5. We will locate the class whose cumulative frequency is greater than or nearest to value of n upon 2. This is called median class. We can observe that 60 to 70 is the class whose cumulative frequency is 29, which is greater and nearer to n upon 2, that is 26.5. Hence, 60 to 70 is median class. Median can be calculated using this formula. Here, L is the lower limit of median class, N is the number of observations. Cf is cumulative frequency of class preceding median class. F is frequency of median class. H is class size. Upon selecting the value, L is equal to 60, N is equal to 53. Cf is equal to 22. Which is cumulative frequency of 50 to 60. F is equal to 7, which is frequency of median class 60 to 70. H equals class size, that is 10. Upon simplification, we get median is equal to 66.4. Instead of cumulative frequency distribution of less than type, we can also use cumulative frequency distribution of more than type. This is an example of cumulative distribution of more than type. Number of students who scored more than or equal to 0 is 53. Similarly, number of students who scored more than or equal to 10 is 53 minus 5, that is 48, and so on. Same table of marks distribution of 53 students by cumulative frequency distribution of less than type. Now, we will plot the points corresponding to the ordered pairs for which class. The ordered pair is given by upper limit of class and corresponding frequency. The coordinates are plotted on a graph paper and joined. The curve which we get is called a cumulative frequency curve or an ogive. In a similar way, we can plot the graph for cumulative frequency distribution of more than type. This is the distribution table for more than type distribution. The ordered pair is given by lower limit of the class and corresponding frequency. The coordinates are plotted on a graph paper and joined we get such a curve. To get median of the data, both ogives are drawn on the same axis. The two ogives will intersect each other at a point called M. Draw a perpendicular on x-axis from this point. The point at which this perpendicular cuts the x-axis gives us the median. Here, the median of the data is 66.4.